So when we started writing the standards, we looked at a lot of sources, we listened to a lot of people, but one of the important sources of information for us was to look at the standards of other high-achieving countries as measured by international comparison. For example, the high-achieving East Asian countries, Hong Kong, Korea, Singapore, Japan. And it was important to us to figure out what it was they were doing. You could do worse than emulate success. And it was pretty clear from looking at those standards that there was a focus in elementary school on building a really solid foundation in number and operations. That seemed to be the most important thing to really think about in elementary school. How could we clear out the quite frankly, mess in some cases of US state standards where there were lots of interesting things going on in elementary school, lots of fun things going on, but also a lack of focus on that basic job of getting kids ready with number and operations. So we wrote the standards to be fairly clear about that there's a focus there. One of the ways we did that was to think about organizing the standards into domains rather than these long strands that go from kindergarten to 12th grade. A domain in the Common Core State Standards is a slightly smaller chunk of material, a slightly sort of more focused stream of ideas that has a beginning and an ending point. So for example, the core number and operations domains in elementary school are operations in algebraic thinking, number and operations in base 10, going from kindergarten to 5th grade, and then fractions, going from 3rd grade to 5th grade. That solid foundation of number and operations prepares students for a really rich experience in middle school where they now can start working seriously with statistics and probability, looking at data. They can start beginning to think about what they need to do to represent mathematics symbolically, in other words, prepare for algebra. That preparation has really been there in that operations and algebraic thinking domain since kindergarten. But in middle school, they start to have experience with algebra. They also have really rich hands-on experience with geometry. And middle school is really meant to be a sort of an area of growth, of blossoming out, because they've got that rich foundation, that solid foundation in number and operations. In high school, we wrote the standards to help students become real users of mathematics, not just to sort of absorb a whole bunch of material. So often high school seems to students to be just this morass of stuff they have to learn that doesn't hang together. And we wanted to write the standards to make clear that it does hang together. Mathematics, that's what it does, that there's a structure there, that there's a coherence, and we wanted students to really, in particular in algebra, for example, have an understanding of not just how to do the math, but why you were doing the math and why you were performing the manipulations you were performing. In other words, mathematics has a purpose. One of those purposes is applying mathematics to problems that arise in other disciplines, in science, in engineering, problems that arise in thinking about data that you see day to day as a citizen. And so we had a big emphasis on modeling, taking some external situation and then making it a mathematical problem. That's what we mean by modeling, and that's an important focus of high school. There's also a continued focus on statistics and probability in high school. Geometry, I like to think that we've really succeeded in bringing geometry back as a serious subject in the high school curriculum. So the progression from kindergarten, from elementary school through to middle school through to high school is all designed to eventually produce students who really know how to use mathematics, can do something with the mathematics they've learned, not just sort of regurgitate procedures that they've memorized.